Okay, so now example 2. Okay, so here example 2 will be more difficult than example 1, but it's okay, we can learn slowly. Okay, so now when the switch S in figure is closed, calculate the effective resistance, the current recorded by the emitter, which is here, and then the potential difference recorded by the voltmeter here. Okay, so now we label all the resistor. Okay, so this will give us R1, this R2, R3, R4, R5, and R6. Okay, so now we can see that R2, 3 are in series, and then R4 and R5 are in series, but then R2, 3 and R4, 5 are in parallel. So first we need to simplify this first. We need to make R2, 3 into one resistor, and then R4, 5 into one resistor, and then we can combine it into series by using the parallel formula. Okay, so now we can do for R2, 3 and R4, 5 first. So R2, 3 equal to R2 plus R3 because they are in series. Okay, so and this will give us 4 ohm. And then R4, 5 are also in series, so R4 plus R5, which is 2 plus 2 equal to 4 ohm. Okay, so now the simplified circuit will be like this. Where this is R1, this is R2, 3, this is R4, 5, and then this is R6. Okay, so now we can see R2, 3 and R4, 5 are in parallel, and then we want to make this into series, so we can use the formula for parallel, effective resistance for parallel, which is like this: R2, 3, 4, 5 equal to 1 over R2, 3 plus 1 over R4, 5. Okay, now we can substitute all the value that we get just now, which is 1 over 4 plus 1 over 4 power of negative 1. And this will give us 2 ohm. Okay, now we can see we can now look at the simplified resistor again. Okay, so the simplified one will be like this. This will be R1, and this will be R6, and this will be R2, 3, 4, 5. And now we can see that all resistors are in series. So we can calculate the effective resistance using the effective resistance formula for series, which is R1 plus R2, 3, 4, 5 plus R6. Yeah, okay, so 2 plus 2 plus 2 will give us 6 ohm. And this will be the answer for question A, 6 ohm. Okay, so now we focus on the current recorded by the emitter here. Okay, we learned just now that for current in series circuit, so current here are connected in series circuit because here the current flow only in one direction here, and then it is separated here into R1 and R2, but then here it combined into R1 and R2 are combined into R1. So here for combine into main current, so this will be the main current I. So we can use the characteristic for the series circuit for the current, which is I equal to I1 equal to I2 equal to I3. So it means that the current flow is the same. Okay, Okay, to do B, we need to use the formula V equals to IR. And then V here we can use from this, which is 6 volt. And then the resistance, we can use the effective resistance since we need to calculate the main resistance, right? Main current, I mean. Yeah. So we can just substitute. Okay, so now we need to rearrange the formula into V over R, and then V is 6 voltmeter, and then R is 6 ohm, and this will give us 1 emitter. So the current recorded by the emitter is 1A. Okay, so this is the answer for part B, which is 1A. Okay, and lastly, calculate the potential difference recorded by the voltmeter here. So we can see that the voltmeter are arranged in series, and in series the potential difference will be potential difference across the cell equal to the sum of the potential difference across each the resistors. Okay, so now we need to use, we still need to use this formula, which is V equals to IR, and we need to calculate V. And then the I is the main current, since the current flow through each resistor are the same. And then the resistance we can just use the value for the resistance one. Okay, so we can plug in all the value. This will be 1, and then R equal to 2. So the voltmeter, the potential difference recorded by the voltmeter is 2V. And this is the answer for part C. Okay, so that's how you do example 2.